Hello everyone, my name is Avkash, and if you have seen this neural network image which talks about perceptron, feed-forward network, deep feed-forward network, and various other types of networks, and if you have thought, what if I could create my own feed-forward network, or what if I could create my own perceptron first time, this tutorial is for you. In this tutorial, I'm going to help you to build your first perceptron, your first feed-forward network, your first deep feed-forward network, and your first CNN, convolutional neural network. And I am very much sure that you must have seen this image one way or another. If you are in the field of data science, AI, machine learning, data engineering, Python programming, etc. This image has been floating around since 2016, and one way or another, people have already been fascinated about the types of neural networks and how to use them, how to build them, how to really consume them for a particular problem you have. So in today's tutorial, I will going to help you to build few of these networks what you are seeing in your screen as of now. So, so today our plan is that we are going to build the perceptron, then we are going to build the feed forward network, and after that we are going to build the deep feed forward network. We are also going to build the CNN or the convolution neural network here. The sum of other neural networks such as RNN, LSTM, and autoencoder is also part of my plan, and they are coming in my next 2 or 3 tutorials. So if you are interested with that, just please give me a little more time. Today's plan I have already explained to you, and there are variety of neural networks as you could see here. We are going to cover some of them depending on how we progress. But today's plan is that let's try to build these 3 different networks today, including convolutional neural network, which is part of feed-forward network. So you can say that the CNN is also a type of network, comes within this category. That's why it is not listed here. If you do not have this image, you can please visit to this tutorial GitHub repo. It's called Python projects and folder is deep learning, and you can get this document available for you. Please print it and just stick in front of your table. You're gonna be enjoying, because in our tutorial we are going to cover majority of these neural networks, and my plan is that during these tutorials and hands-on guidance, anybody who is enjoying these videos, they could build these networks just by using Keras and their Python programming language. For those who haven't seen my previous 2 lectures, please do visit these 2 lectures. One is just a neural networks understanding with code and visualization. This tutorial is available on YouTube, and that is going to help you to just get your feet wet. You are going to figure it out how a simple Python code can be converted into a neural network if written correctly, and that network can be visualized. This tutorial, which I have created yesterday, it's just like a 24 hours back, and there I have helped a beginner or the very first time user to create their very first neural network in Python using Keras and TensorFlow. We are not creating neural networks in Python by writing every piece of code. Instead, we are using Keras and TensorFlow as our main library to build our network. It means we can stand on the shoulders of the giants. They have already built everything, and we just build on top of their framework. So that's where it is. So please, these 2 tutorials are very important for you to learn what we have heard in our plan today. So once again, if you haven't subscribed my channel, I would kindly request you that please subscribe it, because it helps me more excited. It motivates me because it shows me that people are liking what I'm creating. So please do so, and I would deeply appreciate from bottom of my heart. Today, I already have a bunch of Jupyter notebooks ready for you, but they do not have any content. As you see here, that some of these Jupyter notebooks, they have just definition built into, but most of the things we are going to build as we are going to progress. So this tutorial is going to be really very fun. If you haven't built the neural network, not a problem. Today is your day. If you haven't understood what was the perceptron and what is feed forward, what is deep feed forward, not a problem. CNN, not a problem. By end of today's tutorial, I am sure that you will have a great understanding about what these different neural networks are and how you can write them. Majority of the math and other functionality related with the neural networks is coming next, like one or two tutorials after. Right now, I'm just trying to give you the framework, the architecture, how everything really look like just a basic groundwork. And once you understood these very simple things, then we can start building our knowledge top of it. So this is the way I found it was very useful for me to understand, and I helped other of my colleagues to understand, and I'm using the same methodology with you. So this first tutorial is the recap from yesterday. Yesterday we have learned, or yesterday or maybe the previous lecture, just one more time, the previous lecture is tutorial number 2, create your first neural network. So in the create your very first neural network, this is what we have essentially learned. We learn 3 different ways to create your network, and those ways we have used second way and third way. First way I didn't tell you. So today I'm bringing the third way. And if we look into creating the neural network, as I mentioned that we are using TensorFlow and Keras. Very first thing, we are importing the TensorFlow and Keras and some of the modules which are in TensorFlow and Keras here. We have imported input, dense layer type, the model types are sequential and model. So very first time when we created our very first neural network, we used this method because a neural network has one input, one output, and in between inputs and output, there are a collection of hidden layers. Each layer has various number of units of neurons. So that's what you are going to explain in your layer definition. And as you could see here, our input is input with the shape 128 by 128, and the weights or the biases are 1. Then we have added hidden layer, and this layer has the 64 neurons. It does not use bias, and the connectivity for this hidden layer is the input layer. So input layer, then hidden layer just next to it. We are creating another hidden layer which is also type of tens. Number of neurons are 10. Bias is using 10, and connection between hidden layer 1 and 2 is that hidden layer is connected with hidden layer 2, and third layer is the out, and this we are creating a model we are defining which has input is the input and output is the layer number 2. It means by defining this you are going to get your model 3, and if you look into this model and look into this model, this is your model. Input layer parameter 128 128 1, then it's 64 that's neuron, then next is 10, so 64 times 10, 640 plus 10 is 50. So that's why this is because bias is true. If bias is false here, so 64 times 1 is a 64. So that's how you got parameter, and combining 64 plus 650, 714 parameter. We have done this whole thing yesterday or previous tutorial. So if you haven't got it, please watch that everything. Now we are doing exact same thing but different way. We defined our model is sequential. We have added input layer, and then pretty much same way we have added, and when we define this model, as you see here, this model is being built based on how we have created the input, output and layers. And as you could see here, this is exact same thing. Here it starts from input, here as you could see here, and layer 2 and layer 3, and that's our input of the type shape. Again, number of parameters are exactly the same. So these two are identical neural networks. Plain neural networks, if we try to go and look into the definition of these neural networks, I would say that we are just coming there. We are recapping what we have learned yesterday. So this, and now I'm going to show you a third way, which is very first time we are doing is that we are defining everything in a manner where this sequential, where we have created a model and we have added all these layers, we are defining this model all at once. As you see here, first layer 64, it has neurons, input is 128 by 128 and 1 is its bias. Bias is false. Let's look into the model 1 summary, and that is exactly the same like your other neural networks. So what we learned is that there are three different ways in Keras you could define your neural network. We have already seen yesterday that you could use import Netron, and using Netron you could launch your model visualization code, and I'm just showing you here. So you can select any of the model. You need to save that model to the disk. So model.save, and here you will define the model name. So you can say model temp.h5. So we are saving h5 model type. That model will be saved to the disk. We can validate that our model is available here, model temp h5. Then we are using Netron, and we can say netron.start, and we can pass this model name. So I will define this is model name is this, and start and port 8081, and here is our model, and here are the different layer and kernel, and here is our model. We could make this bigger here, and these are the properties. As you can see here very quickly that we have saved a particular model. This is the input 128 120 by 1. Kernel is 1 of 16, 1 times 16. So 1 is your bias and 64 numbers of neuron, and here we are use bias or not bias. So depending on what your choices are, you could create these layers, and thus as you see here, kernel bias. First there is no bias, second there is bias, and activation layer is linear, because if you do not define your activation layer, your activation will be by default linear activation. In some place I think we have defined the softmax. So if I try to, in this model 3 we haven't defined the activation, but if we have here, so if I take this model 3, I can say here I would like to define the activation too. Model 3 has activation now. We can save the model 3, reload here, and as you see that our activation is added as a softmax. Previous one is a linear because previous layers we haven't defined. So same thing, you can take this Jupyter notebook, save it, and you can visualize your network. So at least we have got ourselves warm, ready, and now we can go and start looking into what is the plan for us today. So our plan today is that we need to build Perceptron feed-forward network and deep feed-forward network and CNN, convolutional neural network. So I do have very first Jupyter notebook which is related with Perceptron. You can go look into this particular blog, which is very popular for what the hell is Perceptron. So Perceptron is a single layer neural network. It means in Perceptron, if you look into this image, there is input cell and there is output cell. Perceptron. Output will be your layer because there is nothing output like per se. Output is basically your one layer. So you have input and there is a one layer, or the way you really try to say. It doesn't have any hidden layer. The feed forward network is a perceptron with minimum one layer. If you say deep feed forward, difference here is that it's a fully connected. First, I'm coming there what is fully connected, but in simple term today, as of now, the deep feed forward network means you have 2 or more number of hidden layers. So that's a feed forward network and deep feed forward network. So let's, in very layman term, little complexity with the definitions are coming little later. So we were at Perceptron, and here I was talking about the blog. So Perceptron is a linear classifier. So it's just, used for supervised learning. That Perceptron consists of 4 parts: input, weight and bias, the net sum, and activation function. So there is a lot to learn here, but before even go to complexity of math and activation and anything, just learn very simple. So our target today is that let's build the Perceptron. So here I have TensorFlow and Keras imported, and here between in these areas we are going to build our very first Perceptron. So if I look into here, this whatever you have here, actually if you think about this, if you take this example, okay, here is your input and you have defined your model, you have added input, you have added a layer, and if you try to use this, sorry, we need to add the sequential models, import sequential, and we also need to have the model. And now if we try to take this model and say summary of this model, this is just a single layer network, and this is your Perceptron because we have just added input. It has one layer, which is the output layer, and it has one activation. It also has its weight, bias, and that's pretty much it is. So even if you try to define this way, or you just say that this is your, and this is your Perceptron. So in general, Perceptron is this. So if somebody asks you, have you built Perceptron? You have built it. Yesterday we built several times our Perceptron. We built Perceptron. We have also built our feed forward network. The only thing, I was not bringing these words to you. So you have got an idea that this is Perceptron. Now, if you would want to build Perceptron again using this method, let me take this code because easier for us. And we can build another Perceptron here. Here is our input, and the output layer will be, so if I say output layer, I will not be, and let me call output layer this, we don't need this, and input will be connected here and output layer will be connected here, and we just call it model 2. Model 2 was this, so model 3. Let me make sure model 2 is still there. Model 3 is there. Let's look into the model 3 dot summary, input and dense layer. So that's one way you have found, or if you would want to define your Perceptron the very first way, you could also define this way. So let's define our Perceptron here too. We just call it model 1, and it has 2 layers, so we have to change it. So we can say this is our 10. We can add activation. This is our model 1, and that's where it is. So you could see if you would want to add the use bias is true. Now you see. So 10 times 1 plus 10, 20. If you say use bias is false, it will be 10. So 10 ones are 10, plus there is no plus 10. But this is your, it's very classic Perceptron. So I just wanted you to understand that Perceptron is basically a neural network. It's a full working neural network. It's just a very small neural network which has a one input layer, its weights and its biases, okay, and its output is basically the total sum, the gross sum. And what is the gross sum? That is defined here, and we are going to learn this whole math, etc., in the next tutorial. I just want to spend 2 tutorials to just talk about the architecture of these neural networks. So you have built your very first Perceptron. If you would want to take a look, it's a pretty much same way. You just save your model and you can visualize them here. So if you want to save the model, we can use the same definition here, model name, and we can save, if you want to save model 1 dot save model name, that's our, and if you want to see the, this is our model, and now we can just reload here. You are getting. So this is a really classic example of showing up your simple model. So after the Perceptron, Next comes the feed forward network. So let's go to notebook number 2. So definition is still the neural network, input, output, and layers. Perceptron we have seen. So now it comes to what is a multi-layer perceptron. So the perceptron is a single layer. Multi-layer perceptron is basically your regular neural network. So if we come back to our image here, these are your regular neural network because they are not single layer perceptrons. So that's definition of that. So a classic multi-layer perceptron is a feed-forward network composed of fully connected layers. So the fully connected layer is going to come again and again, and fully connected layer, the way you can understand is that, so in fully connected layer, the total number of neurons, they connect with all the neurons again. So here in case, if you have 4 here, you have 4 here, so 4 times 4, 16 connections are there. Each one is connected. There is none of them are not fully connected. It means feed forward, you are moving your information from one layer to next to next to next. So feeding your forward. That's okay. There is a one word is going to come later. This is a back propagation. This is how they try to understand each other as the layer information move from one layer to another. That definition we will learn in next few lectures. So feed forward, you are feeding the information from last layer to the next layer. Fully connected means all the neurons in the layer are participating in that information transfer. That is very important. So we understood the perceptron here. So fully connected layer, fully connected network is basically fully connected layer because layers where the neurons are fully connected. That every neuron is connected to the every neuron in the next layer. So that's pretty much fully connected. The feed forward network is a definition, and feed forward network means no cyclic connection, just one-way connections are there. That's why if you look into some of these networks such as RNN, recurrent neural networks, LSTM, they have a circle. It means there is a way for information to move different direction. So we are going to learn those little later too. So the information flows in one forward direction, hence it is called the feed forward model. The feed forward network back propagation for training the network. So there is a term called back propagation. Today let's forget that we have heard about it. We will talk that thing tomorrow. So now the question comes, feed forward versus deep feed forward network, which we have seen here, feed forward, deep feed forward. So feed forward network is not a perceptron. It means it has one hidden layer into it. So you have to have a hidden layer. Next, a deep feed forward network has 2 or more hidden layers to it. And there is one more property is that they are fully connected. So we have understood, we have defined our feed forward network. Now our objective is that we have to build it. So if somebody asks you what is regular neural network, you can say the neural network, which is not a perceptron, is a pure regular neural network. And this everything could come within that definition. Here, if you remember, these are basically the regular neural network. They have multiple layers, so they are by definition is the feed forward network. So if I want to build a feed forward network, I will take one of these examples. I need to define from Keras dot models import model and sequential. So here we are defining. I would say that I'm adding another layer, dense. Let's use 32. This is our model 1. This is our model 1 and input, and whatever input you are sending is just passing as it is. It's that there is no changes happening, and that change does not happen a lot when you are using transactional data. So you have age, name, and different labels, etc., and you are passing into, you are not reducing those. However, when we are looking into the images, the unstructured data, we are going to take that image and we need to process them in a different way, and that different way is called the convolution, where you take the image data. There is a very good example is to understand very quickly that if you have a 4 inch by 4 inch picture, And what you do is that you just create a very small stripes of that whole image vertically. You are taking like a 2 mm stripes, so you cut it there. And even if you remove some of those stripes, like you can remove 50% of those stripes, and you put that picture back, you are still making almost 99% of the sense what that object was on that picture. Because even if you have removed some of those information from that picture, but your brain is able to conceive that. It means the information is reduced, but it's not lost. And that's where the convolutional is. There is a mathematics behind it. So that's why it is called the convolutional neural network. And that's where you are taking the input and you are performing different processing on it. And that's what we are going to learn in CNN. But for now, this is your network, which is a feed forward regular network, that we are, whatever the input was, it's just going as it is. So if you try to say that my input is actually the 24 features, and if you pass into, look into your all the 24 features you are passing. So 24 is your feature, one is your bias, and then after that it is using by default the bias. First it's not using bias, but if you say I'm using bias, and now you are going to use 64 times 1 plus 64, 32 times 64 plus 32, and then 32 times 10 plus 10. So that's the number of parameters you have. And that is your way to define your network. You can keep adding. So for example, you were here, you can add one more dense layer, which is type of 16. And if you would want to add the activation, you have opportunity to add the activation here. It is not appropriate to add, but activation is also added. So you are creating your feed forward network, and that's how you are going to define. So either you can use this method or you can use this method. They all are going to be considered your feed forward network. Add here, and you are going to add these layers. 32, 16, your output could be the 1 after that, and then you are saying that let's make 8, 4, 2. These are all number of neurons. This is your model 2. And if you take the model 2 dot, this is your sequential model. If you save model 2, and here we can stop this previous visualization. I don't know if we haven't done here, but we have done here. So I can stop Neutron. If you change the input to that you had 80 features, summary, save your model. As you see here, 128, 128, reload. You have 80 features. So a kernel, if you see here, kernel is totally depending on how many neurons are in previous layer. So 32 times 16, then 16 times 8. So that's where your kernel is, because we are not using any of the bias. But if one place you have decided to use the bias, you selected it, this is your summary, we can save it, reload it. And as you see here, one place the bias is added, because where this 16 bias, and there this bias is added here in this layer. Rest of the layer, there is no bias. So depending on wherever you are using your mathematics, as you see here, in number of inputs, the weights related with your inputs, total weight, everything, that's where, plus the bias. So you have to add bias also, and this is your activation function. Whatever activation function you have, if you are not going to use the activation, it will be linear. So if you are choosing here where you are using bias, you can say I would like to have the activation softmax summary. Let's save it, reload it. Here you have got softmax. It means that when this method, when this layer was passing the information after processing, it has to go with this softmax method to become 0 or 1, or whether information is going to be passed properly or not. It needs some kind of method, and there is a whole list of details which we are going to learn tomorrow, the different kind of activation function, what activation function is and how they work. That will be our target to learn next. So my objective for you was to make sure you understand the feed forward network. So we have understood Perceptron feed forward network and deep feed forward network. Now we are going to look into what are the convolutional neural networks. So convolutional neural networks are kind of feed forward network. The only big difference here is that they have some of the extra capabilities to process the image data. So they are designed to process the unstructured data, especially image data, and that's where you have to get some of the information. So if a feed forward network has a certain kind of structure built into, then it's considered a convolutional neural network. And I have added this information in a way that if you look into the feed forward, we started with regular neural network, then we understood perceptron, then we understood the regular neural network, feed forward and deep feed forward, and now if we add this part to it, now we have understood the convolutional neural networks. You must have a convolutional layer to start with. So that's one thing very easily. It means wherever we are going to create the network, we were using dense layer, we could still use dense layer theoretically. It may not work, it may not solve our problem, but technically you could use it. So we have to use the convolutional layer. There are layers type available. We also need to understand the pooling layer. It has to be fully connected. It means the certain layers are fully connected. It does not mean that it should be fully connected network, fully connected layers. Okay. Then dropout function, there is a dropout function, and then activation function. So if you have a neural network which is feed forward is following this design, then it's considered as a convolutional neural network. There is one more thing for us to understand, something called the deep convolutional neural network, or deep CNN, and that is called the deep CNN here. And there is some requirement for a CNN to be a deep CNN, and it has to have some of the function. The layer must have a particular type of activation function that we are going to learn later. That's why I have put this thing in coming next. And in the coming next, we are also going to look into the activation function, pooling, max pooling, what is a flattening here, what is the dropout here, what is back propagation here, and what are they fully connected, which we have actually understood earlier. So this one we will talk tomorrow, but today let's complete ourselves by building a convolutional neural network. We start with pretty much same way. We have TensorFlow and Keras. We already have this defined. Now I will go ahead and I will use one of these definitions which we have used here. Let's do this and let's build a smallest convolutional neural network. So here, as you see that this is model, I will call it model CNN. So this is that I already have this CONV convolutional 2D layer imported. It means I'm going to use very first layer. So let me clean this whole thing. I'm using convolutional 2D layer. Then I have to define the number of neurons. So I would say let's start with 64 neuron. Then what is my bias? I will give a bias. Then I will use the input. So that will be my input, and if I want to use this is true unless our input shape is going to be 128 by 128 by, so that is we have defined a model CNN and we have defined our convolutional layer. And next we need to add a pooling layer. So this is our max pool. And our pool size is, so now we have 2 layers, so our max pool is added. Then we need to add the dropout. So what is that? We have to add flatten. We are flattening the network. flatten is added. Finally, our output. So dense, final, number of classes, and activation equals soft max. And to be very true, this is a very simple neural network which has 2.5 million parameters, and it's a CNN. It's a convolutional neural network. We have added these layers. We have convolutional, we have max pooling, we have flatten, and we also added our output. So this is your very first convolutional neural network you have just created. By definition, we have followed our concept to create the convolutional neural network. So after you have created your network, we are going to take this. Let's save it. So we have saved it, and the model name is this. So let me turn off the let us stop. Then we can come here, we can start. This is our model, and thus we could take a look, and as you could see here, it has max pooling, it has flattened, and we can look into how the input which was being taken is going to be processed. So tomorrow I will be explaining you the math, why there is 640, why this became 63. If you take this, if you say my pool size is 4, and if you look into now your max pooling, these inputs became 31, why it became like that way. So all those things, the way everything is happening here, I would be very happy to explain this whole thing tomorrow. So please check back again the next tutorial after this, and you are going to enjoy the content. Today our target is to let's build CNN the way we have built earlier. So let's use this method. We are building the CNN again. It's a sequential, so we could define sequential. Do you think you can? Because you have also used sequential here. So this is some type of model. Then you are adding. So very first we had convolutional layer. So you take this whole thing and you define here, and this is your input. If you remember here, so if you would want, you can. So this is your first layer. Second was max pooling. You drop this. Third one was your flatten. Fourth is this. Here is a model 2. Model 2 dot summary, and your model is defined. If you look into here, this is exactly the way you have defined your model as your convolutional neural network. So you have 3 different ways you could create your CNN model too. So third one I will let you create, but you got an idea that how you could create your CNN model. So now what I will do is that I will actually take you and I will try to walk you through an existing CNN model, because we have seen first time today that what is CNN. So I will try to load one CNN model which we have used yesterday, ResNet 50, and I will walk you through to just so you can get an idea what its CNN model look like. So let's take the example. Yesterday we have covered the previously starter, and here was the pretend, and let's use a new Twitter notebook. Let's define the input. Then we need to set our input here, and then finally we just need to take this is our pulling the ResNet, and here include top is true. It is our base model, and if we would want to save, we can actually save this model. This is our base model summary, and we can also save that model so we could analyze it graphically. We have already run this tutorial, so you can run by yourself. So if I want to see base model dot summary, here is your ResNet model look like, but in order to make it much more useful, we can say save, and we just call it ResNet 100.h5. Model will be saved. Now we have ResNet 198 meg model, so we could import Netron dot start 80 81. We have to turn it off from previous running. Stop, and that's where our model was. So if we try to look into the definition of CNN, and as you see that start with convolutional, then there is an activation, there is a max pooling, and you see that activation layers are being merged. Lots of things are happening because this network is 107 depth, so there are 107 layers. So many things are happening here, and tomorrow we are going to, or maybe next tutorials, we are going to learn little more deeper about it. So today's our objective was to cover various types of perceptron network, feed forward, deep feed forward, and convolutional neural network. So we have covered in today's tutorial, and my plan would be that tomorrow we are going to focus our maximum energy on the convolutional neural networks, all the math behind it, and how a convolutional neural network really solve a problem, means how it try to predict if bicycle is bicycle. So we are going to go a little more deeper about the technology, the math, the functionality behind it, and my objective will be that I will make these things very easy for you so you can understand them very easily. Which we have covered today. All of these are available in this common neural networks folder. The resources, some of them which we have used, I have already added the URLs, so please feel free to visit, get to use any of these Jupyter notebook, and the content which is also added at the top of this Jupyter notebook is going to assist you learning. Recap what we have covered today. We have learned that how we could create a very simple perceptron, which is nothing but input and output layer. Second, we have learned how we could create the feed forward network, which is a perceptron with one hidden layer. And if you add multiple hidden layers and they are fully connected, then your network will be deep feed forward network. So CNN is also a type of regular neural network or deep feed forward network, but it must follow certain design principle. It means it must have the convolutional layer, it must have the pooling layer, it must have the flattening layer, and the activation function. It must be followed depending on the type of problem you are trying to solve. Sometimes you are using the softmax, but it is also possible that you can use any other activation function too. So we have covered variety of different neural networks in today's tutorial. Our plan for the next tutorial is to learn the different functionality within the convolutional neural network. So the next tutorial which is going to come after it, that is going to cover detailed convolutional neural network and some of the math, the way the parameters, the way the max pooling is happening, how the max pooling values changes the input type, all that thing we are going to learn in the next tutorial. I didn't miss to cover the autoencoder, LSTM, and RNN. That part will be covered after the convolutional neural network. So thank you so much for your time. I do appreciate your help. If you haven't subscribed my channel, please subscribe it. That makes me motivated and keep going. So thank you so much for your time, and I'm going to look forward to see you in my another tutorial. Until then, thank you so much for your time. Please like it, share it, and subscribe it.